Hello, this is Dr. Raz. In this video, I would like to show you the solution of homework number 1. Let's download PDF file by clicking on three dots, download original file, open that file. Question number 1 is here. What's the degree of distribution D, in degree and odd degree? So let's take a look at the odd degrees. There's one odd degree from D to 1, D to R, that's 1. And in degree, we have M to D and S to D. So 2 in degrees and 1 odd degree, total degree is 3. So the answer for the question number 1 is 3. Question number 2 is directed or undirected. As you can see, it's one-way flow, so it's a directed graph. Question number 3, which one has the highest centrality network? So if you calculate the degrees for each node, S has 1, 2 degree, and M has 1, 2 as well. As we say, D has 3 degree, and R has 1. So the highest is D, which is distributor has 3 degree. So that's why the answer is C, which is distributor is the highest centrality. So question number 4 is asking maximum profit per week. So go to second page. We need to enter this data into an Excel file. Let's start a new Excel file. And here I would like to enter the information. So first, profit for laptops and smartphones. Here we have $200 and $150. And I would like to highlight those two and click on under Home tab dollar, and then I reduce the decimals. Perfect. And then go between two letters. When you see the symbol, double click to adjust the width. Okay, and also I would like to enter this resource requirements per unit. So let's do that. We have two different type of products, Control C, Control V, and then we have truck space in cubic feet, and then we also have driver hours. Okay, truck space needed 5, 3, driver hours needed 2, 3, and the limits are capacities are 300 cubic feet here and 180 hours here. Control B to bold it, and these are my capacities. Okay, now we can build a model. I would like to build my model right here. Click on column D, Control B, choose a different color. And first step is the objective function. In this case, I'm trying to maximize the profit. Okay, I like to use green cell for my objective. And then second part is decision variables. And here I'm trying to decide how many products should I produce. Okay, and I like to use yellow cells for my decision variables. And here I like to calculate the objective into some product of the coefficients, comma, the decision variables, dollar, no decimals. Okay, this last part is the constraints, subject to. I have constraints associated with truck space and driver hours, and left-hand side values versus right-hand side values. Right-hand side values are given, 300, and click on it, right down corner, black cross, drag it, and 180. And these are capacities, so my usage should be less than or equal to those values, those thresholds. I like to use red cell, red color for here. And left-hand side will be some product of coefficients, comma, decision variables. However, I would like to lock the function F4 to be able to drag it to the right. Right down corner, black cross, boom. So click on the green cell, data, solver. Again, if you don't have solver, you can do file, options, add-ins, analysis toolpack, and then click on go, and then check the solver add-in. Green cell, maximize profit. Variables are yellow cells. Add constraints are these values must be less than or equal to these values right here. Click OK. Make sure that yellow cells are non-negative and make sure that this is simplex LP, linear programming. Solve. And the best solution is $13,000. That's the profit that we can maximum generate. The answer is A. Which one is the best in terms of utility? Question number 5. So let's go to page number 3. And here are our alternatives: hub and spoke, mesh network, and platform partnership. And these are states of natures. And here are the, you can see the utilities. Okay, so we need to make a decision. We are trying to maximize the utility, right? So let's enter this information. New worksheet. Let's put here A1, first alternative, alternative 2, and alternative 3. And then we have state of nature 1, state of nature 2, and state of nature 3. So the numbers are 80, 90, 70, 70, 60, 85. And here 30, 60, and 50. So the best solution, if I assume that these are equal probabilities, will be expected value. Let's calculate expected values. Will be, since if I assume that they are equal probabilities, I will just take the average of these three numbers. So 60, 70, and 68.3. So the highest will be A2, alternative 2, which is mesh network. That's it right here. But if I have an optimistic approach, again, the answer is B, if I assume they are equal probabilities. If I'm optimistic approach, I will get the highest number, which again, I would choose A2. If I'm pessimistic approach, I would look at the worst case scenario. In alternative 1, I would end up with 30. And here I would end up with 60. And here I would end up with 50. Still, I would choose A2. Okay. If I'm trying to calculate minimax regret approach, if I go with A2, my regret would be here 10, here will be 15, and here will be 30. So maximum regret here, if I just do this max regret approach, for this one will be 60 minus 30, which is 30. And then alternative 2, zero regret in this situation. Here I have 25 regret. And here I have 0 regret. So 25 is the maximum regret. And over here, my regret would be 20. Here, 0. Here is 10. So 20 would be the maximum regret. So I'm minimizing it. So if I try to minimax regret approach, I would choose alternative 3. Okay. But in this problem, we are asking expected value. So the highest is alternative 2. So the answer is mesh network. That's it for this video. Until next video, enjoy business analytics.